Now, molecules of compound. When two atoms of different elements, they combine to form a molecule. That is the molecule of compound. So, when atoms of two or more elements join together in a fixed ratio, the ratio should be fixed. It will be fixed. When they are combining, it will always be in a fixed ratio. For example, water will be formed in a fixed ratio, hydrogen 2 parts and oxygen 1 part. So they always combine in a fixed ratio. And it is the ratio by mass a molecule of a compound is formed. Now, you have to understand that the elements have to be different to be compound. Hydrogen, oxygen, hydrogen, chlorine, they have to be different to form the molecules of compound. Now, these examples, one atom of hydrogen and one atom of chlorine combine to form a molecule of hydrogen chloride. So, this is one atom of hydrogen, one atom of chlorine. It combines to form HCl, hydrogen chloride. Now, one atom of carbon combined with two atoms of oxygen to form carbon dioxide molecule. So, this is one atom, one atom. This is the one atom of oxygen, one atom of carbon, one atom of oxygen. It forms one molecule of carbon dioxide. So, this carbon dioxide, from this side it's going to take oxygen, from this side also it will take oxygen. So now it has two oxygen, forms CO2. So that is what it forms, a molecule of compound. What is the name of compound? Carbon dioxide. So this is how it is formed. Now here only one hydrogen, one chlorine has formed hydrogen chloride. But here carbon, it has taken two. So now you will see that number of compounds will be formed. Atoms are like alphabet, they form number of words. Same way, this atoms of this elements, they will form number of compounds. Now, every compound has its own specific molecule which are same in all respect but differ in their properties from molecules of the other compound. So, if you take water, the molecules of water all will be same. Their properties will be completely same. Now, if you take sugar, one molecule of sugar, the properties of all the molecules of sugar will be same. But if you see the molecule of water and see the molecule of sugar, they are completely different. So, this is the meaning of this paragraph. Very important for you to understand that every compound has its own specific molecules. Here, water, hydrogen and oxygen. Here sugar, carbon, hydrogen, oxygen. They have specific molecules. So specific molecules are present in each compound. These are the two examples. Water will have hydrogen, oxygen. Sugar will have carbon, hydrogen, oxygen. Now, which are same in all respects. So when molecules are formed, they will be same in all the respects of water. Sugar, all the sugar molecules same, but differ in their properties from molecules of other compounds. They are different compounds. So these properties of the molecule of water will differ from the properties of the molecule of the sugar. So I hope this concept is clear. Now, you take any compound, their molecule, they will be formed of their component atom. The final properties, the property of the molecule will differ from its component also. Let's see the example. Now, here, the examples here, hydrogen, oxygen. Hydrogen is gas, oxygen is gas. They'll combine to form water. The If water is in liquid state, so its property is completely different. Later on you see many properties. For right now you just understand that hydrogen gas, oxygen gas, but water is liquid. Carbon is solid, oxygen is gas, carbon dioxide is gas. So the molecule of compound are completely different in their properties from the atoms of which they are made up of. Take many more compounds. The salt which you take, sodium chloride, sodium property, chlorine property is completely different from sodium chloride when they come together. The molecules of compound. Now, a molecule of a compound can be broken into its constituent element using chemical methods. Now, water is made up of hydrogen and oxygen. You have to separate. So, there's a chemical method to separate. Now, here mercuric oxide is a solid compound. When it is heated, it decomposes. Decompose means separates. Gives mercury and oxygen, which are the elements. So here it is the molecule of mercuric oxide. It is heated, it will separate into mercury, gives an atom of mercury and an atom of oxygen. Now when you want to separate hydrogen and oxygen from the water, you have to pass electric current in the acidulated water. That means you have to put a drop of acid, pass the current and separate hydrogen and oxygen. So when electric current is passed to acidulated water, ionizes to give hydrogen and oxygen. They first form ions and then they form the elements. So here ionizes to give hydrogen and oxygen gas in the ratio 2:1. The ratio of its formation is 2:1. Therefore, when they separate also it is 2:1 by volume. So here you can see hydrogen, oxygen, that's a molecule of water. You pass electric current in the acidulated water, you get hydrogen, oxygen and hydrogen. So 2 atoms of hydrogen and 1 atom of oxygen. Now this table shows some of the compounds and the atoms, the number of atoms which are present in the compounds. So here we see sodium chloride. Now sodium chloride is a table salt which you eat every day. Now which are the atoms present in it? Sodium and chlorine. 1 atom of sodium and 1 atom of chlorine will form a compound which is sodium chloride. Now water, 2 atoms of hydrogen, 1 atom of oxygen, they will combine to form water. 1 atom of calcium and oxygen will combine to form calcium oxide. This is the tuna which you put on the wall, that is calcium oxide. Then sulfur dioxide, 1 atom of sulfur and 2 atoms of oxygen will lead to formation of sulfur dioxide. This is the gas which is emitted in pollution by the vehicles, and it causes pollution. So when you get some itching in your nose due to pollution, it is the sulfur dioxide gas. Ammonia, NH3. Now this bad smelling substance which comes, the smell which comes from the urine is ammonia. 1 atom of nitrogen and 3 atoms of hydrogen will lead to the formation of ammonia. Now sugar which you eat, sugarcane juice which you drink has got carbon, hydrogen, oxygen. So how many carbon? 12 carbon, 22 hydrogen and 11 oxygen will be present in the sugarcane juice. Now you have understood what atom is, what molecule is. So now you have to understand what is radical. Now radical is a charged atom. Radical is a charged atom. Now, 1 atom will be charged. Now, even group of atoms, they come together, behave as one unit and they are charged. So, that is radical. Just then you should know that they are charged atoms, and group of atoms together they develop one charge. So here a radical is an atom of an element or group of atoms of different elements that behave as a single unit with a positive or negative charge on it. So it will have either positive or negative. So one atom or group of atom behaving as one. So they'll have positive or negative charge, and that is why they are known as radicals. Radicals with charges. Now, if they have positive charge, they are known as basic. They have negative charge, then they are known as acidic. Basic, acidic. Positive, negative, basic, acidic. So you have to follow this much. Now, positive ions, positive atoms which have become radicals, they are known as cations. Now negative atoms which have developed negative charge, they are known as anions. So cations and anions, positive charge cations, negative charge anions. So here you have understood about the positive and negative. If they are positive, basic, negative, acidic, positive ions, cations, negative ions, anions. So they develop charges, and if they have developed positive charge, it is positive, basic. If they have developed negative charge, it is acidic. Positive ones, the positive radicals are known as cations, negative radicals are known as anions. I hope you have followed this. Now, positive cations, positive are cations. So, which are the atoms which develop positive charges? Metallic ions. Metallic ions. Now, in addition to metallic ions, nitrogen, hydrogen combine together to form ammonium ion, which behaves like a metal, which is positive ion and which is known as cations. Now, here in negative, the anions are non-metallic ions. They are not metals, they are non-metallic. Then group of non-metallic atoms, non-metal ions, they come together to form group, and they they have the charge which is negative. So this should be clear: basic, acidic, positive, negative, cations, anions, metallic ions, ammonium ions, non-metallic, group of non-metallic atoms. Now, after understanding the radicals, ion comes. What is ion? It is the same thing. It is radical. Ion, radical, they are same. This definition is only for your better understanding. Now, these ions, they are radicals. They are charged atoms. They are electrically charged. They have positivity or negativity. Same things. And that leads to the chemical reaction. So, here the definition of ions: electrically charged atoms formed by losing or gaining electrons are called as ions. You have understood that it has to have charge, positive or negative. But how do they develop charges? By donating electron or accepting electron. Slowly you will be understanding. You have understood the structure of atom. So they will be giving or taking electrons and developing the charges. Now, molecules of compound are usually formed of two or more than two atoms. Now, try to understand the compound which are formed of the two atoms. Now, here sodium, example is sodium chloride. Sodium is one ion which is positively charged. It has developed by losing the electron. It has lost electron and developed a positive charge. So it is positive ion. The atom which has lost the electron has become positive ion. Now in chlorine, it has gained one electron and developed a negative charge. It has developed a negative charge. Now this chlorine, the ion is known as chloride. So it is sodium and chloride ion which will combine to form sodium chloride. Now this is positive, negative, they attract each other, equal and opposite charges, they attract each other and they form sodium chloride which is neutral. So now this compound sodium chloride, the salt, the table salt which you eat every day, is this salt. So chemical combination has taken place this way. Now charge on this radical shows their combining capacity. Now this positive and negative, they have the power of forming a compound. So combining capacity is shown by this charges and that is known as valency. So charge on this radical show their combining capacity that is valency. Now naming an ion or a radical. Simple positive ions derive from the names of their parents. Sodium, sodium ion. Sodium becomes ion by losing the electron. So it has become sodium ion. Now simple negative ions derive from the parent elements by replacing the last few letters of the name by the suffix ine. So the example chlorine, ine. It is chlorine. Now when it has gained electrons and become a negatively charged radical, the ion, then it becomes a chloride ion. Now this is the representation of some positive radicals and their valencies. The hydrogen H+, sodium N+, potassium K+, silver Ag+, magnesium Mg2+. Now all this up till now here they have only one valency because they have one charge. 1 plus 1 charge, 1 plus 1 charge, valency is 1. The capacity to combine is 1, 1, 1, 1. Now up till silver it is 1. Now magnesium it is 2. Now here you can see it is 2. Valency is 2. Calcium Ca2 plus 2. Zinc 2 plus 2. Iron Fe 2 plus 2. Copper Cu 2 plus 2. Iron F. Now up till copper it is 2. Iron you see Fe is 3 plus, that is the valency is 3. Aluminium Al 3 plus, valency is 3. Gold Au 3 plus, valency is 3. Tin Sn, this is the Latin name, therefore it is Sn. 4 plus, valency is 4. Platinum Pt 4 plus, it is 4. So this is the representation of the radical, positive radical and its valency, which is the now representation of some negative radicals. Now you know that the suffix of the negative radical is IDE, fluoride, chloride, bromide, iodide, hydride. So suffix is IDE. Fluoride F negative, 1 negative charge is there. Chloride 1 negative charge is there. Bromide 1 negative charge. Iodide 1 negative charge. Hydride 1 negative charge. Valency is 1, 1, 1, 1, 1. So here when it has got 1 negative charge, the valency is 1. Now here oxides it is 2, sulfide it is 2 negative charge, so the valency is 2. Nitride it is 3 negative, 3 valency. Phosphide it is 3 negative, the valency is 3. So here the valency is the charge which is present here. Here up till iodide it is 1, 1, hydride 1, oxide, sulfide 2, 2, nitride, phosphide 3, 3. Now you have studied the positive and the negative radicals. You have understood it. Now, these radicals are made up of two or more elements. They come together and they behave as single unit and they develop charge. Now, looking at the table, you might find it difficult, but once you start understanding this, radicals will seem simple. Let's see. Now, ammonium ion is the only one which is positive. It has got valency 1. How is ammonium formed? By nitrogen and hydrogen. 1 nitrogen and 4 hydrogen. It has got 1 positive charge, 1 valency, that is its capacity to combine with other element and form compound is 1. Now, hydroxide ion. Hydroxide ion is OH negative. OH negative. From hydrogen, hydroxide is oxygen, hydroxide OH. Now it has got 1 negative charge, its valency is 1. Nitrate ion, NO3, 1 negative, valency is 1. See, there is a change in the spelling, nitrate and nitrite. When it is nitrate, it is NO3, oxygen is 3. When it is nitrite, oxygen is 2. So you have to take the sound of nitrogen, nitrate, nitrite ion, NO3 and NO2. Now valency of NO3 is 1, valency of NO2 is 1. So it will combine with the valency 1. Now next is bisulfate ion, bisulfite ion. Now see the sound, sulfate and sulfite, bisulfate, bisulfite. Whenever bi is there, H will be there, H. Bi is for H. Sulfate, SO4. You have seen nitrate and nitrite, NO3 nitrate, NO2 nitrite. Same way, here sulfate is SO4 and sulfite is SO3. So bisulfate HSO4 and bisulfite ion HSO3 negative. Valency is 1. So only 1 charge is present with both. Now bicarbonate ion. Carbonate is CO3 negative. Bi is HCO3. Its valency is 1. So I hope you have understood up till here. Now acetate. The sound of acetate you must have heard for first time, but try to remember CH3COO. CH3COO, that is acetate. So connect with the sound. Acetate is CH3COO. It has got 1 negative charge and its valency is 1. Now carbonate ion, CO3, up till here the valency was 1. So it's the capability to combine with other element 1. Now here carbonate ion, CO3, 2. So here you remember CO3, 2, that is the valency 2 for carbonate. Now sulfate ion, SO4, 2 negative, valency is 2. Sulfide ion, SO3, 2 negative, valency is 2. Dichromate. Now this is simple to understand, sulfate and sulfide. Now again dichromate. Dichromate Cr2O7. That you have to memorize. Dichromate Cr2O7. Dichromate. And its valency is 2. 2 minus, so therefore the valency is 2. Now phosphate ion, PO4 thrice negative, its valency is 3. So up till here the valency is 1 and then 2 and only phosphate ion it is 3. So as what you have to do is take your notebook and write the name of the radical and its representation. And valency, anyhow, you're going to remember when you remember the charge. So here you go on writing the name of the radical and its representation, and slowly learn. You will know that it is very easy to learn. Once you start writing whatever is given, then it becomes simple to write because there is lot of similarity in it. Now, these are the questions which are made of for atomic structure. Now, let us discuss the question answers of atomic structure. What you have to do is take your textbook, your notebook, and write down these question answers. And you'll never forget the concepts of atomic structure. So, now, what are atoms? Atoms is the smallest unit of any matter which cannot be divided further. So, this is what atom is. It is the smallest invisible, indivisible particle of an element which may have independent existence or may not, but takes part in chemical reaction. Now you take piece of zinc and you go on dividing zinc. So what do you get? You get atom of zinc. Which is the smallest unit of element? Atom is the smallest unit of element. How many atoms you will find on a full stop? Millions. What are the characteristics of atom? Now, atom is the smallest particle of the matter. Now, the atom of the same element will be same and different element will be different. It cannot be divided further. It can neither be created nor destroyed. It may have independent existence or may not have independent existence, but it will take part in the chemical reaction. So these are the characteristics of the atom. What are the fundamental particles of atom? You know the structure. Electrons, protons and neutrons are the fundamental particles of the atom. Now, what are protons, what are electrons, what are neutrons? Protons is the particle of the atom having positive charge and unit mass. Electron has got unit charge but no mass. Neutron has got unit mass but no charge. So these are the three fundamental particles of the atom. Now, what is the charge of the electron and protons in Coulomb? This is taken as unit up till here, but now in Coulomb, what is the charge? It is 1.602 into 10 raised to minus 19. 1.602 into 10 raised to minus 19. That is the charge of electrons and protons in Coulomb. You have to memorize this number. Now, what is the mass of protons and neutrons in grams? In grams. So, it is 1.6 into 10 raised to minus 24. 1.6 into 10 raised to minus 24. That you have to memorize. What does the subscript on E, P, N and minus 1 plus 1 and 0 represent? Subscript is one which is given below. Superscript is one which is given above. So, subscript of E, this is the charge. Minus 1 is the charge. For P plus 1 is the charge. For neutron 0 is the charge. So, subscript, they represent the charge. What does the superscript on EPNS01 plus 1 represent? They represent the mass. Electron has got negligible mass. This has got the unit mass. That is for the proton and neutron. They have unit mass. Why do atoms of different elements have different number of electron, protons and neutrons? The physical and the chemical property of all the element is different. These particles, they decide the physical and the chemical properties, so they are different for different elements. Now, in which atoms protons and electrons are always equal? In neutral atom. When protons have got positive charge, electrons have negative charge. When they are equal, then the neutral atom is formed. Now, label this. This is the structure of the oxygen atom. Here, in the circular orbits are the electrons. In the center is the nucleus, which has got protons and neutrons. If you are given to label this way you have to label. What is a molecule? Molecule is the smallest particle of a pure substance, which is either element or a compound. Now, it is capable of independent existence. How many atoms are present in the molecule of hydrogen? 2, H2. How is the molecule of water formed? 2 hydrogen and 1 oxygen, that forms the water. What are the main characteristics of a molecule? Now, the 2 atoms come together, they are chemically attracted, chemically bonded, a charge is developed, therefore they are chemically bonded, and it's the chemical combination of the atom of the same elements of the different elements. Now, the properties of one molecule is same of the many molecules of that substances, and they always combine in a fixed ratio, and that ratio is a whole number, and that molecule has a chemical formula. So these are the characteristics of the molecule. How many types of molecules are present? 2 types. One is pure, that is just made up of elements, and the other is compound, made up of 2 or more elements. So here 2 types of molecules are present. Now give example of molecules made up of one atom. Helium and neon, they are the noble gases. They are just one atom. They just form molecule with their own isotopes. The example, helium, neon. Now give examples of atom cannot exist independently, that is oxygen, hydrogen, nitrogen. These are the examples of the atom cannot exist independently. How many atoms are present in the sulfur to form a molecule? 8. How many atoms of phosphorus combine to form a molecule? That is 4. 4 phosphorus combine to form a phosphorus molecule. What is the atomicity? It is the number of atoms which are present in a molecule that forms the atomicity of that molecule. Now, which are the 4 divisions of molecules depending upon its atomicity? Mono, di, tri, polyatomic. Monoatomic, diatomic, triatomic, polyatomic. They are the 4 divisions of molecules depending upon the atomicity. Now give the examples of mono. It is sodium, magnesium, these are, and the noble gases like helium, neon, xenon. These are the examples of monoatomicity. Diatomicity, that is hydrogen, oxygen, nitrogen. They are the examples of diatomicity. Triatomicity, that is ozone, O3. Polyatomic molecules are phosphorus P4 and sulfur S8. Examples of polyatomic molecule. What is the molecular formula of an element? It is the symbolic representation of the molecule. It shows the number of atoms and the types of atoms which are present in it. What does the numeral on the left hand side of the symbol represents? The number of atoms present that numeral shows the number of atoms which are present in the molecule. That forms the molecular formula. How does the molecule of the compound form? When two or more than two different atoms combine together, a molecule of compound is formed. What is the state of the carbon? Solid. In what element mercuric oxide breaks on heating? It breaks into mercury and oxygen. What are radicals? It's the charged atom or a group of atom which behaves as a single unit and has developed charge forms the radicals. Now radicals are of two types, basic and acidic. Acidics, they are anions, and the basic are the cations. Cations are positively charged and anions are negatively charged. With suffixes added to the negative ions, IDE is added, chlorine becomes chloride. These are the negative ions which has the suffix IDE, ide.